evening. My name is Afsoon. Today I will be presenting and talking about electromagnetic spectrum. As you can see, there are about 6 objectives which I will be going through. The first one will be about the principles and properties of types of electromagnetic waves, the properties of microwaves and infrared using selected examples, and the uses and hazards of X-rays in medical applications, compare and contrast the properties of visible and UV light, explain some application of visible and UV light, and the final one will be explain the biohazards of ultraviolet and infrared radiation and their main effects. These are the principles and properties of the types of electromagnetic waves, and we'll be discussing what is the electromagnetic energy. Electromagnetic energy travels in waves and spans a broad spectrum from very long radio waves to very short gamma rays. The human eye can only detect only a small portion of their spectrum called visible light. Electromagnetic waves are trans waves. They all have the same speed, vacuum, but increasing wavelength increase their frequency. The electromagnetic spectrum is a continuous range of wavelengths moving up and down, left and right. As shown in the bottom part of the diagram, the types of radiation, as you can see, that occur in different parts of the spectrum have different uses and dangers, depending on their wavelengths and frequency, as you can see from the diagram. I will be going through radio. Your radio captures radio waves emitted by radio stations, bringing your favorite tunes. Radio waves also emitted by stars and gases in space. Microwave. Microwave radiation will cook your popcorn in just a few minutes, but is also used for astronomers to learn about the structure of nearby galaxies. Infrared. Night vision goggles pick up the infrared light emitted by our skin and objects with heat. In space, infrared light helps us map the dust between stars. Visible. Our eyes detect visible light. Fireflies, light bulbs, and stars all emit visible light. Ultraviolet. Ultraviolet radiation is emitted by the sun, and the reason skin tans and burns. Hot objects in space emit to UV radiation as well. X-rays. A dentist uses X-rays to image your teeth, and airport security uses them to see through your bag. Hot gases in the universe also emit X-rays. Gamma rays. Doctors use gamma rays imaging to see inside your body. The biggest gamma ray generator of all is the universe. All of these waves travel at the same speed in free space, which is the speed of light. As you can see, the next slide will be talking about properties of visible and ultraviolet light. The visible light and ultraviolet light. Generally, visible light is defined as the wavelengths that are visible to the most human eyes. Visible light falls in the range of EM spectrum between infrared and ultraviolet. It has frequencies of about 4 times 1014 to 8 times 1014 cycle per second, or hertz, and the wavelength of about 740 nanometers. As the full spectrum of visible light travels through a prism, the wavelengths separate into the colors of the rainbow because each color is different wavelength. Violet has the shortest wavelength and around 380 nanometers, and red has the longest wavelength at around 700 nanometers. Ultraviolet light falls in the range of the EM spectrum between visible light and X-rays. It has frequencies of about 8 times 1014 to 3 times 1016 cycle per second, or hertz, and wavelengths of about 380 nanometers. UV is generally divided into 3 subbands: UVA, or near UV, 315 to 400 nanometers; UVB, or middle UV, 280 to 350 nanometers; UVC, or far UV, 180 to 200 nanometers. So moving on to the next slide, as you can see, applicants of visible ultraviolet. Also to mention about radiation with wavelengths from 10 nanometers to 100 nanometers are sometimes referred to as vacuum or extreme UV. These wavelengths are blocked by air and they only propagate in vacuum. So moving on, visible light and infrared waves are used in optical fibers. An optical fiber in a thin rod of high quality glass. Light goes into the glass at one end and it undergoes repeated total internal reflection, even when the fiber optic is bent. The light in the fiber optic never leaves the glass and is constantly reflected. Information from computers or telephones can be converted into electrical waves and sent through fiber optic cables. Fiber optic cables are able to carry more information than ordinary cables of the same thickness. Also, they are able to keep the same quality of signal over very long distances. Sometimes the strength of a wave with an ordinary cable weakens over long distances. Cameras use visible light. A lens is used to focus on visible light. We can then control the amount of light that is let into a camera by changing the aperture size of a hole and the shutter speed, the amount of time that the lens is open. A film is then exposed to light and after development a picture is revealed. Laser. Laser ultimately is an example of active remote sensing using visible light. NASA's Geoscience Laser Altimeter System instrument on board the ice, cloud and land evaluation satellite enables scientists to calculate the evaluation of Earth's polar ice sheet using lasers and LRC data. Changes in evaluation over time help to estimate variation in the amount of water stored as ice on our planet. Illumination. Of course, the original purpose of the lamps is to illuminate with UV lamps offering energy efficient. Bright light in many industries such as manufacturing, clean room production, quality inspection and many other applications which require well-lit environment. Backlighting. UV lamps provide backlighting to avionics and aerospace industry, providing reliable lighting in airplane cabins and cockpits. Light sources and our valued partner offer experienced backlighting solution with a light quality UV lamps designed for backlighting found in many demanding industries, including the NASA Space Shuttle. UV clearing. Used in many manufacturing applications, UV lamps for clearing of inks, coating and finishes provide a strength uses for UV lighting coating. Adhesives, varnishes and lacquers coated with UV lamps are more durable and last in demanding environments, such as industrial, automotive and aerospace applications. Tanning. UV lamps are the core technology in tanning salons, offering clients a way to enjoy a sun-kissed look from a man-made technology. Light sources offers many benefits to the tanning industry with the introduction of proprietary technology designed strictly to improve tanning performances and safety. And moving on to ultraviolet. Light technologies are used for multiple purposes in forensic investigation, including alternative paintings and other fine arts, alternative signatures, analyzing questions, documents, illuminating lantern fingerprints at crime scenes and trace evidence on clothing, analyzing ink stains and revealing residual stains of body fluids. Moving on to the next slide. Properties of microwaves and infrared using selected examples. Microwaves and infrared. Microwaves are waves that radiate electromagnetic energy with a shorter wavelength. Microwaves are not reflected by ionosphere. Microwaves travel in a straight line and are reflected by conducting surfaces. Microwaves are easily attenuated with shorter distances. Microwave currents can follow through a thin layer of cable. Microwaves are used for cooking food and for satellite communications. High-frequency microwaves have frequencies which are easily observed by molecules in food. The internal energy of the molecules increases when they observe microwaves, which causes heating. Microwaves pass easily through the atmosphere, so they can pass between stations on Earth and satellite in orbit. Similar to the visible light spectrum, which ranges from violet, the shortest visible light wavelength, to red, longest wavelength. Infrared radiation has its own range of wavelengths. The shorter near-infrared waves, which are closer to visible light on the electromagnetic spectrum, don't emit any detectable heat and are what's discharged from a TV remote control to change the channels. The longer far infrared waves, which are closer to the microwave selection on the electromagnetic spectrum, can be felt as intense heat, such as the heat from the sunlight or from the infrared waves, which are closer to the microwave selection, can be felt as intense heat such as the heat from the sunlight or fire. Infrared light is used by electrical heaters, cookers for cooking food, and infrared cameras which detect people in the dark. Moving on to the next slide. Main effects and biohazard of ultraviolet and infrared radiation. UV radiation has enough energy to break chemical bonds due to their high energies. UV photons can cause ionization, a process in which electrons break away from atoms. The resulting vacancy affects the chemical properties of atoms and causes them to form a break chemical bonds that they otherwise would not. This can be useful for chemical processing, or it can be demanding to materials and living tissues. Both UVA and UVB rays can cause damage to your skin. Sunburn is a sign of short-term overexposure, while premature aging and skin cancer are side effects of prolonged UV exposure. Responses of the human eye to acute overexposure of UV radiation include photocortical and photoconjunctivitis activities, inflammation of cornea and the conjunctiva, respectively more commonly known as snow blindness or Wilder's flash. Symptoms range from mild irritation to severe pain and possibly irreversible damage. Exposure to UV rays can also waken up the immune system so that the body has a harder time fending off infection. This can lead to problems such as reactivation of herpes triggered by exposure to the sun or the sources of UV rays. It can also cause vaccines to be less effective. Prolonged IR exposure can lead to lens, cornea and retina damage, including cataracts, corneal ulcers and retinal burns. A skin exposed to IR provides a warning mechanism against terminal effect in the form of a pain. Sources of IR from hot work applications such as work with molten metals, welding and glass blowing can cause serious burn to unprotected skin. And moving on to the following slide, talking about uses and hazards of X-rays in medical applications. X-rays used in medical equipment to see internal structure of the body parts. Some parts of the body absorb the X-ray waves, e.g. bones, and others let the wave pass through. This allows doctors and nurses to see bone structure and allow them to check if they are okay or not. X-rays can be used to extreme most areas of the body. They're mainly used to look at bones and joints, although they are sometimes used to detect problems affecting soft tissues such as internal organs. Problems that may be detected during an X-ray include bone fracture, breaks, tooth problems such as loose teeth and dental abscences. While X-rays are linked to slightly increased risk of cancer, there is an extremely low risk of short-term side effects. In other words, the risks are minimal compared to the benefits of medical imaging. Exposure to the high radiation levels can have a range of effects such as vomiting, bleeding, fainting, hair loss, and loss of skin and hair, unfortunately. Children are more susceptible to radioactive effects of X-rays. However, X-rays provide such a low dose of radiation that they are not believed to cause any immediate health problems. Coming up to the last slide, this is the conclusion. Electromagnetic spectrum has many uses and applications in manufacturing, healthcare, forensic, as well as the telecommunications. Incorporating electromagnetic application into our daily lives requires certain safety precautions to ensure minimal level of biohazard for human. Thank you very much for taking the time to listen to my presentation. Feel free to please send me any questions via email, and I look forward to responding to. And this is following the references if you like to get more information and read about things in more details. Thank you for your time.